Good evening, good morning, everyone. So today's agenda is all about blockchain. What is this entire world talking about, and why the entire world is talking about blockchain? How is it going to change our lives, or is it like worth it? If we are talking about digital currency, if you are talking about metaverse, if you are talking about anything else which is related to blockchain and how it is going to work and all. So we are going to take a look at that all. The agenda of today's session is issues with current banking systems, then how Bitcoin solves these issues, then what is the, you can say, Bitcoin transaction, Bitcoin to the rescue, then Bitcoin concepts, features, use cases, and hands-on, right? So now let us discuss about issues with the current banking systems. So what are the issues with current banking systems? So first, high transaction fees. So whenever, let's say, Chandler tries to send some $100 to Joey, and what happens is Joey receives only 98 because $2 are deducted as a transaction fee, which is taken by bank. So JP Morgan Chase, Bank of America, and Wells Fargo alone earned more than 6 billion from ATM and overdraft fees in 2015. So you can realize that this is 2022. So we are down the line, 7 years down the line. So maybe 2015 it was 6 billion, probably it can be 60 because of the high amount of transactions which are being happened right now across the globe, the number of users, internet speed. There are many factors which might have affected this entire number. Then the second main problem is double spending. Now what happens is, let's say you have Peter has $500 in his account. Now he writes a check $400 to some boy, and he writes the same you can say $500 check to a girl. So what happens is Peter has only $500, but he can write the check of $900 cumulatively. That is not going to happen. So probably whoever gets the check first, check cleared, will get the money, and the other one maybe have a bounce check, or then she or he has to call the bank and check what went wrong and all. But at the time of giving the check, Peter is safe because Peter can transfer the money irrespective of whether he has that money in his bank or not. So bank transactions are prone to double spending, first thing. Then whatever crisis we had in last, you can say, decade or so, the crises were during the depression and fractional reserve banking and all. So basically what fractional reserve banking is, a part of bank money is reserved as a fraction, and then eventually they utilize that to do some business and all. But all this cumulatively together gave us that last crisis. I'm talking about the economic meltdown we saw. So the point is, what we are looking at right now is the current banking system. What are the issues which in the current banking system? Not just these issues, but these are some main issues. One more issue is, let's say if you want to send some money from here to US or from here to some other country, then it will take at least 3-4 days, from bank to bank transfer even. And then eventually again the same rates will be, we will not get the same conversion rates and all. So that high transaction fees also is there, and apart from that the waiting time is also there. So the point is, there is one more problem. Now we saw that, okay, the current banking system has this problem. So how Bitcoin is going to solve these issues? Now the question is, what is Bitcoin? So we all know that Bitcoin is a currency. It's a digital currency. So it's a cryptocurrency. It's a coin, but not a physical coin. So we are used to have physical currencies in our hands since the beginning of mankind. Let's say whenever we started to have barter systems, and then we had coins, and then everything, then cash. So the point is, we are still like, we feel that you can say flavor of a note or maybe a coin in our hand, but this currency is completely decentralized, or maybe you can say this currency doesn't exist in the real world. It's a virtual currency. So point is pretty simple over here. So what is Bitcoin basically? So Bitcoin is a currency, as I told you before. It's a cryptocurrency. So how that currency can be utilized or can be deployed over a network or over computers or something like that. So basically in somewhere around 2008 or so, or before even that, somebody wrote a paper about DeFi, that is decentralized finance, right? You can say DeFi, you can say DeFi, whatever you want, because it's a mixture of two words, decentralized finance. And what exactly is that? So basically, we are going to remove the entire centralized system. Either it can be banks, it can be government authorities, it can be anyone. So the transactions will happen directly from person to person. Let's say similarly in our country, we have this Paytm applications, right? So Paytm allows us to transfer money from our mobile number to our friend's mobile number. Now again, it is associated with bank, but for us it takes milliseconds to transfer that money, right? But when it goes to banks, it takes time. So over here, Bitcoin was released as a white paper, and then Satoshi Nakamoto released that white paper in 2008, and then someone released this entire coin. Now, either that the person is the same one, or who are the creators of Bitcoins, nobody's aware of. Even Satoshi Nakamoto is a person, group of people, male, female, nobody's completely aware of who is it, because that's a completely anonymized person. Now, the point is that they have the idea of DeFi, and that gave the birth of Bitcoins. So you can see the first line is written Bitcoin blockchain as a distributed ledger. Now ledger we all understand. We have been using banks, let's say since last 200-300 years. Now the point is banks have everything in terms of entries, our passbooks, our bank statements, and everything. So the banks keep a ledger, and we keep that passbook. So that those both entries need to match. So basically what it can do, what it can be considered as, it's a double entry ledger. Now let's say you transferred some money to your friend's account. So what happens is, now that bank account, let's say you have your bank account in State Bank of India, and your person has a bank account in Punjab National Bank. Now when you transfer 1,000 rupees from your SBI account to his PNB account, so the point is his PNB account will also have that entry, and your SBI account will also have that entry. And this is what is known as double entry ledger, right? Now the first most important thing is decentralized power. So basically in blockchain world, there is no central authority. Everybody has the same power. The same way we have a power to vote, right? Being a citizen of our country, India, we have a power to vote. So can anybody say that my vote matters more and someone else's matters not, or maybe matters less? No, because every vote has the same capacity, same weightage. The same way, every person associated with the blockchain network has the same power, and that's why it is known as decentralized power. Public ledger, so it's publicly available for everybody to access. It's not like hidden. Let's say if a government or any other organization in the world receives some money which needs to be spent for some reason, then that actually, because it is not public information, either you need to go there, you need to take a help from a lawyer or something like that in order to get the exact information, but it's not publicly available. You cannot be a part of that ledger, but here you can be immutable to hacks. Now that is the most beautiful part of blockchain world, immutability. Now what is immutability? So basically immutability is you are not allowed to change anything which is recorded in blockchain. That means, let's say if I have entered some data, let's say I have my wallet created in blockchain, and that wallet has 2 Bitcoins or 3 Bitcoins or whatever the thing is. The point is, if somebody tries to change that data and he wants that information or maybe something out of it, you can say he wants to add 230, maybe he wants to reduce by 1, or he wants to reduce by 0 at least. So the point is that is not possible. Why? Because let's say hypothetically there are 100 computers which are running this blockchain software that is basically known as node. So hypothetically, if you understand, let's say there are 100 servers which are scattered across the world, and 100 scatters run the same website or the same things. For blockchain, that is the thing, that every node has the same sort of ledger entries. Now what happens is, let's say if a single hacker tries to hack a system, so he can hack a single node. Let's say hypothetically, if we figure that, okay, he can hack a single node, but the other 99 nodes will have a different data, while that one node will have a different data. Why? Because that data is now somehow changed by someone. But the point is, consensus will not be achieved. Now, what is a consensus? So the way we achieve, you can say there is an issue and we try to resolve that issue. Now we have to match the number of people who are either in agreement of that issue or in against of that issue. So that is how we achieve consensus in our real life. So that basically gives us an idea that, okay, if 51% of nodes, entire blockchain network, if 51% of nodes agree, then yes, then the data is correct. If less than 51% nodes don't agree, then it doesn't matter. The transaction will be discarded. That means the system will not allow that transaction to be recorded in a block. Why? Because that transaction was changed. So the how that will change and how that will affect the entire blockchain, I'll showcase at the end while demonstrating the demo. But point is, this is how it works, that you cannot change. So it is an insert only database. Hypothetically, if you are saying it is an insert only database, you cannot change anything which is recorded. But that doesn't mean that if by mistake, if you have entered some wrong data, you cannot correct them. You can, but the point is it will leave a trail, right? Then no double spending. So we saw that over in current banking system that you can either write down a check for the more amount rather than your current balance in your bank account. But here, Bitcoin can take care of that double spending, right? How? We'll see at the end. Now, how Bitcoin solves these issues. So first problem is high transaction fees. Over here, the high transaction fee is not there. It is either zero or very minimal. Now, zero we don't expect, so we can expect very minimal, right? And main thing, now let me tell you that what is the difference there? That even banks have that transaction fees and even Bitcoins have the transaction fee. Then the question is very simple. Why Bitcoins then? Why not stick to the banking system? So the challenge over here is banks, even let's say if you own a credit card, then you are supposed to pay for that credit card fees for the entire year. Whether you use it or you don't, doesn't matter. You are paying certain number of rupees for that. You are having a bank account for that, service charge also is there, whether you are using that bank account or not, but service charge will be there. Even in some cases where banks, like, you don't operate your account very often, then there is a separate charge for the same also. But here in Bitcoin's world, or especially in blockchain world, you don't pay if you don't use. If you transact, then only you pay. If you don't transact, you are not going to pay anything at all to anyone. And that is the beauty of this platform. So how does a Bitcoin transaction look like? So what is a Bitcoin? I already told you that somebody released a cryptocurrency based on the white paper written by Satoshi Nakamoto, and that gave the birth of Bitcoin. So Bitcoin is not blockchain. Many people have that idea that Bitcoin is blockchain. No, blockchain is a technology using which Bitcoin is released, right? So let's say if you say that Amazon is a website. No, Amazon is a website created, or Amazon is a technology. No, Amazon is a website using, let's say, PHP or .NET or any other technology which was used. But Amazon is not technology, just a website, amazon.co.in or amazon.com, whatever it is. So the point is, same way, Bitcoin is not blockchain. It's a coin released, used the technology called blockchain. So as you can see that there are a number of blocks you can see on the screen, and one more block which is added. So whenever a new transaction happens, then the transaction gets recorded into the block, and then the block gets added, or you can say gets added to the system. Now how this matters is, if you can see the first block over here, this block, the second block, third block. So the first block is called as Genesis block. That is the beginning of your blockchain journey. Then these blocks address is associated with this block also. So what happens is, whenever this new block is created, it will take this previous block's address over here, and then the third block will take the second block's address, fourth block will take the third block's address. And to generate these particular you can say addresses or values, there is one sort of other mechanism which works under the hood, and that is known as Merkle tree. Now I cannot cover what is Merkle tree in just 1 hour of webinar. The point is, Merkle tree is sort of a hashing function. Very simplest terms, if you ask me, hashing is a one-way function. Now what is a one-way function? So whenever you hash some data, you cannot get it back. You can generate a hash with the same data and compare the hash. If they match, then you have the same data, but you cannot get the data back once you hash it. The same way over here, all the blocks are connected through that, you can say previous addresses and all, and that becomes a chain. So whenever this new block gets created, it will accept the address from the previous block, and then it will be added to the network. So that is, again, what is Bitcoin? So it's a first decentralized digital currency. Then it uses cryptography to control its creation and management. What is cryptography? You might have studied in your college engineering or BSc, IT or MSc IT curriculums. Cryptography is a very important subject because it deals with security, and it has been dealt with, you can say, even when the computers were not there. So at that time also some sort of low level cryptography was there, but currently we have like sh algorithms, we have this MD5 algorithms, and every algorithm which exists right now in order to, you can say, encrypt any sort of data you want, that entire thing which is covered, that is known as cryptography. Third is created and held electronically in a peer-to-peer open ledger, and which is known as the blockchain. Now, created and held electronically in a peer-to-peer open ledger, which is known as our blockchain. What does mean peer-to-peer? It's like your computer, your friend's computer, and his friend's computer, maybe my professor's computer, and all these computers are connected and becomes a peer of the network, right? So that because we don't have any centralized authority, so every peer is connected, and every peer, maybe hypothetically for now, let's say, has the same sort of power. And that's where every node which is associated with blockchain is known as peer. And how does ledger is produced? Ledger is produced by people using software that solves mathematical problems. Now, what is a mathematical problem? So basically, whenever somebody tries to write down a transaction, then a mathematical problem is sent to the network, and whoever solves that mathematical problem gets to write the transaction in the blockchain world. And this entire process is known as mining. Now let's see how the Bitcoin transaction works. So over here, let's say James, so this person wants to transfer 500 BTC to Kevin, to him. The transaction is a part of a block. So new block is there, and that will be validated by miners Lisa and Robert. So this is miner, and this is one more miner, Robert. Now I just explained you what is mining. So over here, there are some special nodes which have the capacity of mining. Now what is mining? So in our world, real world, let's say you want to have gold, or you want to have silver, or any other metal, let's say copper or whatever it is. You need to mine them from the earth, right? Now that is why, in order to have that same, you can say, terminology over here, the term in order to generate a new Bitcoin, or in order to write down a transaction, the thing which is known as the entire process is known as mining. So for us, let's say if I want to generate one Bitcoin, now Bitcoin is not a physical currency that I can go and print. So what needs to be done? Then I need to mint. I need to mine. And after that mining, what is mining? That cryptographic puzzle, which I solve using my computer. And as soon as I solve that, I get a chance to write down. And that's how I mine a coin. And this entire process is known as mining. Now, what does this miners get then? So in our decentralized system, there is no centralized system to validate the transaction. So what will happen is, in our case, let's say if James wants to transfer some money to Kevin, then who will record this transaction on the blockchain? There has to be some person, but that person is not fixed. In our case, let's say there are thousands of, you can say tens of thousands of miners scattered across the globe. So whoever gets to solve that puzzle gets to write the transaction. But in order to do that, he needs to have some sort of setup machine, high-end configuration machine and all. And that's where he gets the money from the gas fees, right? And that is how the miners earn, you know. So from the transaction fee, there is some very small amount which is known as gas fee, which is paid to the miner. So in Bitcoin transaction, even let's say in your bank account, your total money is always presented by the bank, right? It always stays in your database. But here in Bitcoins, it is not the case. It adds everything together and every transaction together, and at the end it decides that, okay, how many dollars or how many Bitcoins rather are there in your current account. So basically there is no central column over there which says that, okay, this account has this many bitcoins or what. Once you spend, then the transactions are there, and by adding together all those transactions, the remainder values, you will get the balance. All right. So you can see that 500 minus 500 plus, but again, we are talking about balance only. We are not talking about the final balance. We are talking about the balance of the transaction only, right? Let's say very simple. If I say that, okay, if I want to transfer 8 rupees to my friend and I transfer, let's say I have 10. So all the 10 bitcoins will be transferred. So that transfer, that person will get 8 bitcoin, but 2 bitcoin will be there in the manner of unspent transactions, right? So over there, if I study the transaction, then I can say that, okay, I have 2 bitcoins in my account, right? That is how it works. Then again, we have already seen that Lisa and Robert, they have used their resources in terms of hardware, in terms of electricity, and for that they are paid from the transaction, whatever happened between James and Kevin. From that, some transaction, some money is already, you can say, put aside for that particular miner, whoever gets selected, and that particular money or piece of coin is known as gas fees. So once the block is validated, money is deducted from James's account and transferred to Kevin's. And this was the problem of double spending. Why? Because that transaction has the same value. Otherwise, before that, let's say because the transaction gets recorded over there and you have only 2 coins, then you cannot generate one more transaction which allows you to transfer 5 bitcoins to someone else. That's how it takes care of double spending. Now, finally, Lisa, the miner who gets a chance to record the transaction, gets 12.5 BTC. BTC is a short form of bitcoins as incentive, which becomes the first transaction of the block. And what happens is after that, that record becomes the permanent part of the blockchain network, right? Now, how blockchain achieves the Bitcoin solution. So we have seen that, okay, current banking system has these problems. The digital currency can solve these problems. Now, how? So someone requests a transaction. The transaction is broadcast to the P2P network. For us, let's say there are 100 computers associated running the blockchain network, or they are a part of this blockchain network. Then it is broadcast to everybody, to every miner who is active right now. Okay. Then validation happens, right? And then once verified, the transaction becomes a part of the new block of the ledger. And then, as you can see, the previous blocks are, you can say, recorded in terms of orange, and the new block is now green. And once that this part happens, then the user gets a notification that, yes, my transaction is now complete. So that is how the blockchain, you can say, transaction works. It is quite similar to whatever we are used to see in the cloud server architecture. The only portion is this validation and this adding to the network that doesn't work in our regular systems, right? So this is a sample blockchain, the first blockchain, first block of the blockchain, which is known as your Genesis block. And then eventually, whenever the new transaction happens, then it keeps on adding to the new blocks, and then ultimately your blockchain network grows in terms of blockchain database. Because again, blockchain records some transactions, so it has to use database also. It's not like that blockchain doesn't use any sort of database. Blockchain uses database, but in a different format, right? So that is how I guess 𝐂𝐝𝐿DB or something, which is used at the bottom. But again, every platform has its own sort of version of database and all. Hyperledger Fabric uses 𝐂𝐝𝐿DB and LevelDB. So you need to study the platform in order to understand that, okay, what is the underlying database being used by this blockchain technology, right? So again, new block, if you can see in the previous slide, the new block was there, then it was added, it becomes a part of the blockchain. Now a new block is created and that it is being added. So that is how the entire system works. Now, blockchains are built from 3 technologies. First is your blockchain program, which is in other word known as smart contract. Then wherever you deploy your smart contract, so in your P2P network, and where you and how you generate the entire chains of blocks, and private key cryptography. Now, what is private key cryptography? That is used to secure identities and hash functions, which we already discussed in the previous slides, to make the blockchain immutable. So immutable is what? You cannot change it, right? Then P2P, again, because every node has the same data and no node has some other sort of version, and that is how we achieve consensus mechanism or consensus among other nodes. That okay, if somebody tries to change one record from some other node, then if all the other nodes don't agree, then it becomes difficult for the person to change. Then blockchain program is basically your smart contract. In other word, you can say it's a protocol which is used. Now, what is a private key cryptography? So that is basically over here. If you can see that two different keys, one is private, the other is a public. So basically you can say that public key is known to everyone, private key is known to you only. One key is purposely kept private, that is provided to the other party, often the public, not the private one. To encrypt, then the public key can decrypt and vice versa. And this is called asymmetric encryption. So what is an asymmetric encryption? You encrypt your data using your private key, but you give the public key to someone where that other person uses your public key and gets to decrypt the data, but he will not be able to see which private key you use to generate the you can say encrypted data, right? So that is the beauty of it. Then P2P network. So you can see that over here, A, B, C, all these nodes are, all the dots, the black and green dots are the peers, or you can say in other words, nodes of the current system. So over here, you can see that suppose A finds the transaction, Bobby B pays 5 coins to Cindy C. So this is the transaction which was generated by B, and the transaction ended to C. So here B, Bobby sent 5 coins to Cindy C, and A means your miner. So that miner finds the transaction that okay, this is a transaction which needs approval, or we can say which needs validation. Then what happens is node A, because node A got the chance to mine the transaction, then it broadcasts to the peers A and B in the network, right? Sorry, B and C in the network. Why? Because A is directly connected to only two nodes, B and C, and that is why whenever A gets a chance to write an you can say transaction, then it sends to B and C. Then if the transaction is verified, the peers B and C, so B will forward, let's say this is B, this is E, then it will forward to this two. Now this is C, so let's say this is F, this is G. So everywhere, every node will then broadcast to the connected node. And this is how that every node, whenever a new transaction gets written on the blockchain network, every node gets the same copy. Maybe in terms of receiving time can be different, but every node will have the same copy of the transaction. So what happens is you have, let's say there are hundreds and millions of transactions happening on the world right now in this blockchain world. And if you sync all the data, let's say in terabytes, whatever the blockchain size is, you can see the first transaction to the last transaction from the genesis block to the last block, right? So that is how the P2P network works. And transactions propagate rapidly across the network, as we discussed that 1, 2 these connected nodes, and then more connected nodes, and third and fourth and all so on. So every now and then whenever transaction gets recorded, it will be broadcast to each and every one, right? Then P2P network, that is your distributed ledger. So you can see over here, ND has $10, or ND transfer 10, then Bobby sends Derby $3 and Derby sends Cindy $1. So over here you can say ND sends $5 to Bobby, Bobby sends $3 to Derby, and Derby sends $1 to Cindy. Now this is a distributed ledger. Now let's see. This is a copy. If you can see, the previous copy has different transaction, but the only copy. So what does this mean? This is a centralized ledger. Why? Because the banks have the same copy. Probably the same bank, then the only bank has the copy. If it's a separate bank, then maybe two banks, but again, only banks have this transaction, right? Over here, you can see that everybody, Andy has the same transaction, though he's not associated with Bobby and Derby's transaction, neither Derby and Cindy's transaction, but still Andy has the same transaction on his node. Same goes for Bobby, same goes for Derby, and same goes for Cindy. So what happens is everybody has the same transaction, irrespective of whatever you can say, if you are a part of the transaction or if you are not a part of the transaction, doesn't matter. Because it's a public ledger. So whenever somebody transacts something, then it will be publicly visible. Now the question is, why would somebody like to do that? Because then if I transfer some money, then that will be visible to someone, to everyone. But the point is the wallet accounts are completely anonymized. There is no way in the world that can be traced back to you. So even if somebody gets to see that, but again, that identity or the everything can be encrypted in such a way that nobody will be able to see that, okay, what happened between these two wallets. Now, digital signature. So what is a digital signature in regular world? So let's say if you want to sign a transaction or sign some document. So you use a hash algorithm like this over here. Then you generate a hash based on your data. Then you apply your private key and encryption. So what happens? This document completely now a different document, which becomes a digitally signed document, right? Then it shares, let's say it goes to your friend or who needs to have this document. So that once it is received, then what happens is you need to have that decryption key, or you can say public key. And based on that, the combining hash algorithm and decryption key, the signature is valid and which has hash values are equal. Because these hash values are equal, what does it mean? The data is not changed. Somebody, let's say hypothetically, if somebody changes some data over here, and what happens, this hash and this hash will be different to each other. And that's how the verifier will be able to understand that the data is compromised, right? So that is how the digital signature works. Now blockchain program. So again, it's a smart contract which you can write down in order to accept, or in order to, you can say, and make any sort of transaction or make anything happen, you need to write down a smart contract. Now that can be using any language, Python, JavaScript, Node.js, Golang, Solidity, many languages are there, right? But for public blockchain, Solidity is the most preferred language. Then blockchain transactions. So we already discussed that all the transactions are logged, including the information on time, date, participants, and amount. And every node has the same copy of the blockchain, right? Transactions are verified by miners who maintain the ledger after solving complex mathematical puzzles. Now, don't think that there will be a mathematical puzzle which you can solve on your hand, in your notebook or something like that. No, this is basically, even you don't need to click on some button to get the you can say transaction. It is all completely automated. So whenever a new transaction is broadcast to the network, if your node is active, it automatically picks up, joins the queue, and whoever gets to solve the problem for the first, it has to produce, the node has to produce that, okay, the node has solved the problem, and that is known as proof of work. That proof of work is the concept of Bitcoin. So that is the reason that if you keep on hearing that term, that too much electricity usage and all, that is because of this. Why? Because let's say there are 100 miners in the race. Whenever a new transaction is there, 100 miners will try to mine the transaction, but only one gets a chance to mine, and then gets rewarded with the gas fee. But what about other 99? Because they also have used electricity, their hardware, they don't get anything. So that is the reason that mining is extremely expensive in Bitcoins. So that is the mathematical principle which ensures that the nodes automatically and continuously agree, which we discussed in terms of your consensus mechanism, right? And whenever somebody tries to corrupt, the other nodes will not accept, and automatically the transaction will be discarded. Now, the most important part in blockchain world is whenever you hear something about coin, something about crypto, something about tokens, then you are talking about public blockchain, right? But when you talk about supply chain, when you talk about healthcare, when you talk about insurance, then it automatically becomes a private network. Why? Because that data cannot be made visible to public. And that is the reason that we don't need a complete public solution over there. Over here, again, the principles are the same, but that network is restricted. Whoever has the access, only he or she will be a part of the network, and not everyone else. Third one can be a consortium. So what is a consortium? It's a group of organizations, banks or something like that. They can verify transactions to the ledger, but ledger is open to all. But the point is, the verification or the miners maybe can be done by using a consortium. So in a single line or in a nutshell, if you want to say, the use of mathematics to create a secure distributed ledger which enables transactions without the need for third parties. So what does it mean? You don't need banks, you don't need government authorities, no centralized authority is required. It's completely automated network. Even if I release a smart contract and I want to change the smart contract after deploying, I cannot. In any other programming world, this is possible, but in blockchain, that is not possible. Once it is deployed, it is deployed. I cannot, even the creator itself or himself cannot change it. So that is the beauty of this technology. Now, what are the blockchain features? So fraud resistance, yes, consistency, maintains incentives in terms of your gas fees. Fraud proof, we already saw that, how that is completely fraud proof. So it's a distributed ledger. We already discussed that too. And the main thing is no trust model. Why? As I right now told you that whenever you want to do business with some other party who is not known to you, there is always a chance of, let's say, fraudulent activity or malicious activity. But here, the network is automated. Nobody can disturb the network. Nobody can change the network. So whether you trust the person, whether you don't, doesn't matter. That's why it is known as no trust model. So currently the Bitcoin reward is 12.5, but currently it is still down. It is a bit old information, and the price also is different, but because it gets changed every single day, right? Now the most important part: which particular domains or which particular use cases can be possible using blockchain? So banking, payment and transfers, healthcare, law enforcement, voting, online music, real estate, something like that. All these things, all these domains which are, you can say, very near to our life. Every day we have to use banking services. Every maybe 3 years, 4 years, 5 years, sometimes we have to vote. We payment every single day. Healthcare probably at least 3-4 times a year. Music every single day. Real estate maybe once or twice in lifetime. Law enforcement, hopefully we don't need anything from law enforcement, but again, because they handle the entire security piece and all, it can still, blockchain also can be a pretty decent use case for them also. So here what blockchain can do for banking? So it could cut up the $20 billion in a middleman costs per year. That's a huge number, right? Hacking into banking ledgers, impossible. Banking ledgers become close to impossible and reduces bank crisis by a large extent. So in our case, no middleman, yes. Immutable, yes. Fraudulent proof or hack proof, yes. And there will be no crisis. Why? Because there is no central authority, there is no fractional balance, there is no depression or something like that. Okay, so that is how it can revolutionize the entire banking sector. Payment, again, because it's a wallet address which is there, software wallet in terms of your MetaMask or in your browser or any other service you are using, the money gets transferred immediately, right? Without any transaction fee or very, very less transaction fee, irrespective of the country. Even if you are in US, if you are in UK, Germany, Canada, any other country, it will take fraction of seconds. Voting, yes. In countries like us, whenever some party wins, the opposition party always claims that there is some mislead or there is some issues with the election and all. But here, if we use this, then authentication of voters can be identified properly. Secure record keeping can be possible, and then again, there will be zero chances of any sort of lost records or foul play or any sort of voter fraud. Plus, it gives voters also the confidence that, okay, the election is secured, election is not, their vote is not going to be wasted. That can increase the voters turnaround also, right? So this is what it is in all about blockchain world. There can be separate cases in terms of public and private blockchain. The use cases can be different. The points can be, you can say, whatever you want to go with, you can go with in terms of, you have to identify that, okay, which one basically is your use case, and based on that you can decide whether you want to go with public or you want to go with private blockchain. Now we saw that in public blockchain or private blockchain, anywhere, this is the same one. We saw that every block is connected using previous hash. This you can see over here, the previous hash is 0. Why? Because it's a genesis block, right? And the block, that particular block's address is now this one, hash. This is your address, previous hash. Block 2, you can see that previous hash and this hash is similar, 000015. Over here 00015, right? This hash again becomes the, you can say, this third block's previous hash is the second block's main hash, right? Now let's say what happens. I write down something. Now what happens? Slightest change and the hash is changed. Now because the hash is changed, this particular block lost the connection. So what happens then? You have to mine that block. And then you have to mine this block again. You can see the hash is changed. Once you mine that, then it becomes a part. And then again, the third block or whatever the number. Now the point is pretty simple. If anybody changes something over here, it has to change to each and every block, and which is not possible for anybody, right? And that is the reason that this technology is completely hack proof, that it is not possible to hack this entire piece. Though you must have heard about that, okay, it is possible somebody transferred some coin and all, but that is okay. Point is, the coins were never be able to transfer in terms of fiat currency, right? I hope you understand what is fiat currency. So fiat is our dollar, rupee, pound, and anywhere government currency is known as fiat currency. And anywhere the digital currency which we talked about is known as your cryptocurrency or tokens or coins, right? If you go to block part over here also, you will be see that this is the block ID, the nonce, which is a very random number, and the data. And if you change, mark the size of the hash, it will not change. I'll just keep my cursor over here. If I write down something, you can see that the hash gets changed, but not the size. That means nobody in the world can identify that, okay, what data is exactly written in this, right? If I just delete everything else, then it will be there. Why? Because the hash, the block is already mined. But if I even put a dot, it will change to something. And if I need to do that, I need to mine that block again. And that is the beauty of hash. Now, if I remove hash, what will happen? It will again have this same problem. Why? Because now you have changed. Now, in order to get this transaction right, you need to mine the transaction again. And that is the main, you can say, immutability of blockchain world, that this blockchain technology cannot be hacked by anyone. It's not possible. Theoretically, practically, it is not possible, right? Now, let's say if you want to just see a contract deployed somewhere, or just want to see how a contract looks like, then just go to your browser, open this site, remix.ethereum.org. On the left side, you will be able to see the workspace, and under that, you will be able to see these contract files under the contract folder. And if I just write down, say, select a single contract, on the right side, you can see that the entire code is written. And this is basically your Solidity language, right? And once you deploy, then how does it look like? So you can go over here and you can just deploy. And at the bottom, you can see that, okay, the transaction is mined and execution and all. The transaction hash is generated from which wallet to which wallet and everything. What was the gas fees and every other detail about that transaction is now, you can say, permanently recorded on your blockchain. So this is how this entire piece in terms of blockchain, programming, Bitcoins, everything works, right? So thank you very much, guys. Have a nice day.